start recording. Okay, so I think this is useful. Okay. Okay, all right. So recording has started. I would like to say that this should be right at your fingertips, but I think I shouldn't say that because these are not easy formulas to remember. If let's say if you get confused, if you are easily confused by the symbols, but I think that these are the things that you guys should have it right at your fingertips. Okay, unfortunately, but rest assured that any formulas that are more complicated than this will be provided. Okay, so let's say I ask you a question that requires a certain string function. Let's say, okay, let's just say, okay, which is more complex than this. Let's say, maybe a string function associated with, let's say, a ranking full body. I'm just saying. Then I'll give the string function of the ranking full body there. Okay, all right, and then from the string function, I'm quite sure if you are able to memorize VR equals to del phi by del r, and 1 over r over, sorry, 1 over r del psi by del theta, then you guys should be able to work out the VR and v theta yourself. Okay. Okay.
Okay.
I know it can be a little bit
Confused.
Yeah, but it is common. It's a common thing for students to memorize the simple ones.
Okay.
Yeah, I'm sorry, man. I'm sorry. I'm sorry. Yeah, because you know what, we have to be fair because I think we've been reminded by the school that we have to be consistent between the full-time students and the part-time students. So
okay.
Yeah, so if we want the full-time students to memorize the simple ones, we have got to do the same for the part-time student as much as possible, of course. Yeah.
Yes.
But I think in this case, it's fair. Yeah.
It's just like the multiplication times table when we were in primary
Yes. Except the multiplication timetable is probably a lot simpler when you're like primary 2 or primary 3. Yeah. So
all right.
Sorry to disappoint you, young lady. Yeah.
Okay. Just keep memorizing.
Yeah.
Okay. Thanks, Prof.
Okay, no problem.
Okay.
Okay, thanks very much for the question. How about the others?
Hi, Prof.
Hi, is this
I have a question for tutorial 2, question 4.
Okay.
Right.
Let me pull up the thing.
Have a look.
Yeah, let me pull up the thing. Tutorial. Or are you able to share screen? Would it be easier? I'm not too sure.
Okay. Give me a moment, right?
Let's see who gets there first. Okay. Tutorial 2, question 4. Okay.
Yeah, actually, it's regarding one of the questions. So I don't have it on my computer. I actually wrote down.
I got it. I got the question. I got the tutorial already. Let me share screen. Okay, maybe that will help to refresh your memory. Okay. Yep.
Okay, when you already combine. Okay, sorry.
No, go ahead.
Yeah, for question 4, right? When you combine the velocity potential, right? Initially is in Cartesian, so you need to convert it into polar form.
Correct.
So for the x component, right, it is changed to 2r cosine theta. But at your chapter 2, of the lecture notes at page 21, it says for the r component is changed to 2r sine theta. Yeah. So what's the standard actually when you want to convert from the x component to
it's always x equals to r cosine theta.
Okay.
The tutorial. Let me. Okay. Why don't we do one thing at a time first? Okay.
Yeah.
Let me just do this. R cosine theta. Hang on. I must have put it somewhere.
Because the lecture note is the x component is actually r sine theta.
Hang on, let me share screen because it's r cosine theta here. Hang on. Can you see my screen?
Yes.
Okay. You're talking about this page, right?
Yeah. So you see, note that x equals to oh. Okay. I think something wrong. There's something wrong with my notes, because my note shows is r sine theta.
How
For the
about
x
y?
component.
How about y?
Y shows that r cosine theta.
Eh? That's odd. Let me pull up the notes. Hang on. Let me pull down the. Okay, there could be some issues here, some mistakes. I do apologize if that's the case. Thanks very much for the question. I think this is very important.
Hi, Prof. My notes
Yeah.
is x equal to r cosine theta.
Yeah.
Probably I have
Correct.
the older version of the notes.
Oh, but did
Maybe.
you pick up the set of notes from a senior? Because that's what some people do, you know.
Yeah, I think I did.
Okay.
Okay.
Because I look at the notes that I uploaded into NTU Learn is x equals to r cosine theta. So I think what happened was that the set of notes that I got that you got from your seniors, right, has got this error, but I corrected during the lecture, and maybe the person did not cancel or whatever.
Okay, got it.
Okay,
And
sorry for the confusion. Yeah.
Yeah, no problem. It's really my fault. Yeah.
Okay.
So I got another question. It's for question 7.
Question 7.
For the tutorial 2.
Okay.
For the sync component, right? When you want to find the velocity,
Mm-hmm.
there is a negative sign. Is a negative sign because it's a sync, or is a negative sign because it's the opposite direction of the source?
It's negative sign because it's a sink. Because think about it, right? As the name implies, a sink is something. All right, basically, okay. Under potential flow theory, a sink is a singularity whereby fluid goes into the sink. Okay, so by convention, all right, if fluid is disappearing into the sink, all right, it should have a negative sign. All right. Conversely speaking, for a source, what is a source? A source is basically the opposite of a sink, whereby fluid is coming out from a singularity or from a point. So that's why for source is positive strength, whereas for sink, it will be negative strength. Okay, I think I mentioned this in the lecture notes, I believe. Yeah. Okay.
So
Yeah.
for that, so if that's the case, the sync will never have the negative. No, sorry, a sync will never have a positive sign convention. Am I right?
Correct.
Okay, got it.
Correct. Let me just show you
Even
this.
though if the direction is even though the direction is the same as the source.
But how can the direction be at the same as source? Are you talking about the direction? Wait.
The
Let me
velocity
check.
direction.
Okay, wait. When you say velocity direction, I think got to be clear. Okay. So this is a source and sink, right? Okay. So you see, this is a source. How do we know? Because fluid, as indicated by the blue streamlines, are coming up from the one point. So if that's the case, right, that means flow is actually flowing outwards from this one point. And in that case, the strength of the source will be a positive number. If these arrows are opposite, that means all shows going in instead of coming out. All right, then the strength will be a negative, will have a negative sign. Okay. All right. I'm just wondering, I'm just putting out there, Ashraf, I'm just curious. Is the reason why you're asking me whether the sign is negative and positive because of the way that we resolve them in the horizontal direction and vertical direction?
Yes, that's exactly what I'm asking.
Okay. So what happened is, okay, first thing first, I would say that when it comes down to source and sink, okay, if we have to use their velocity components, right, sort of like adding them up or minusing them off, okay, we always start off with their rate of velocity first. you can see from the screen, right? We always have to find out the radial velocity associated with the source and the sink. So you see for source 1, there's no negative sign because it's a source. So the direction itself, the VR itself has got this magnitude. The same goes for source 2. All right, there's no negative sign in front because it's a source. So the velocity VR, the radial velocity for source 2 is also a positive number. For the sink, you'll notice that there's a clear negative sign here. Okay, that's why the radial velocity for this sink will have a negative number. But in this case, there's no negative sign here because it's moving here. Okay, now when we want to find out the net velocity components in the x direction and the v direction, you have to see where the VR are being resolved. Is it resolved in the positive x direction or is it in the negative x direction? Is it in the positive y direction or is it in the negative y direction? And that's why I think then you have to do this plus and minus thing carefully, as shown over here. Okay, so maybe I'll just use this example. So let's say we have all the radial velocity components of the source, of the two sources and one sink. So at point A, let me just use the highlighter. So at point A, the horizontal velocity component, so let's say at point A, the velocity component will be, of course, the velocity, all the horizontal velocity components that come from the source, from source 1, source 2, and the sink. So for source 1, if you think about it, it has a radial velocity of what? 0.0159 everywhere, radially. And along this line, because point A lies along the same horizontal axis as source 1, so source 1's contribution to the u velocity component will be its radial velocity directly, 0.0159. As for source 2, again, it lies on the same horizontal line as point A, so its contribution to the velocity at point A, once again, is a positive 0.0265. Okay, because you have this component here, right? You have this arrow here and this arrow here, which tends to push the flow into this direction. Okay, now we have one last one. Okay, how about the sink? Think about it. The sink will be slightly different because you know why? For the sink, right, it tends to pull fluid from point A towards the sink. All right, it tends to pull this way.
Okay.
All right. So if it tends to pull this way, oh no, how am I supposed to draw this? Oh, okay, sorry about that. So if it tends to pull this way, okay, that means we have to take this velocity component, right, and then resolve to the horizontal axis by taking the cosine. Correct?
Right.
Okay, so that's, and then because it's now moving from right to left, no longer moving from left to right for source 1 and source 2, like what source 1 and source 2 are doing. So that's why we have a negative sign.
Okay.
Yeah, so that's it. Yeah.
So let's say if the source 2 is not at this spot at maybe 1 meter above, so you just resolve it accordingly, use the proper cosine, and it's a positive lah. Am I right?
Correct, correct. If that's the case, right, for this 0.0265 radial velocity component of source 2, over here you will have a number, let's say cosine certain angle, yeah, or a fraction like this. Yeah. Okay.
Yeah. Got it.
Okay. Right. Good. Good. Thanks very much for the question. Yep.
All right, thanks.
Yeah. No problem. Okay. Yep. Good. Yeah. I think for CAs, in fact for any assessments, okay. I think sometimes, right? If let's say you're more comfortable in using things like sine rule or cosine rule to solve such questions, because sometimes it is possible, rather than resolving them in the horizontal direction or in the vertical direction. That's fine as well. Okay. Okay. Because if let's say at the end of the day, all you need to know, all you need to find out, all you want to find out is actually the magnitude. Okay. It's possible to use cosine rule or sine rule. Okay, that's fine as well. Okay, so long you are consistent and you manage to get the answer, it's perfectly fine with me. Because depending on the flow situation, sometimes it's quite troublesome. Sometimes it's quite troublesome to resolve this, resolve that. And some more enterprising students, they say that, hang on, I remember my cosine rule, I remember my sine rule. Why don't I use that to solve the problem instead? Yeah, then I say, by all means, just go ahead. So It's really up to you. This is just one way of solving this question. Okay, and there are some people who prefers to use I and J. They like to use the unit vector. They like to use unit expressions. Sorry, not unit expressions, vector expressions. All right, that is fine as well. Okay, I would say that so long when I check through answer, you're able to show me that you understand the flow scenario. Doesn't matter if you use vector expressions or use cosine rule or sine rule. All right, you get the answer means you get the answer. Okay. Yeah. Okay. So good. Yeah. Okay. Excellent. Right. Okay. Is this mode of interacting sort of like Q&A better? I hope it's better, man. Yeah, because to be honest, because sometimes I'm not too sure what you guys what will work best for you guys. Because again, like I think I mentioned in last week's session or 2 weeks ago. Okay, I think there used to be a case whereby past years. Hang on, am I still recording this? Okay. I'm still recording. Let me just stop the recording.